Hi friends, welcome back. Today we're talking about triangle similarity. So before we can get started on the actual triangle similarity, we do have to go back and do a quick refresh and a little bit of background work on proportions. So let's talk about proportions for just a sec here. Okay, so first a reminder on proportions. Grab your notebook, make sure that you're taking notes here. So when we see a proportion is just comparing two ratios, and ratios are just fractions. So when we have two fractions that we're comparing, we call that a proportion. So generally it looks like fractions equals fractions. So when we have here is fraction equals fraction, and when that happens, that's so fun because the easy way to deal with this is what we call our cross products. That's what this is, cross products. I will move my head out of the way so that you can take that note. I guess it's only kind of in the way. So you can take notes for your notebook, cross products. So what we do here is we say, okay, this times this equals this times this. So again, that's going to be 2 times x equals 2x. And then equals 4 times 4, which gives us 16. We want to get that x by itself, and we're currently multiplying. So the opposite of multiply is divide. Divide both sides by 2, we get x equals 8. And if you go back and you look at that, that seems pretty logical because 2 is half of 4 and 4 would be half of 8. This is a nice easy one where you get whole numbers. That doesn't always work out though. So you definitely want to learn and use that cross products. And so here's a generic form of those cross products if you need that. Okay, so let's talk now about scale factor. So scale factor is all about scaling things up or down. Where you may be most familiar with this is if you have a picture on your phone and it's small on your phone, but you want to print a bigger picture and put it on your wall. When you go to print that picture, you want it to stay proportional, meaning that you don't want your face like stretched out or really skinny, so that you want it to look the same as what it looks like on your phone. That is called keeping things in proportion. Another good example of that would be if you have like a model car. So when you have a model car compared to a real car, maybe the wheel of the car is like a tiny portion of the actual car. It's like maybe 1/8. Well, on our model car, we want the wheel to be proportionate, meaning we want it to also be 1/8. We don't want it to take up like half the car. That's not going to look right. So that is proportion. We're going to scale things up or down by using what we call a scale factor. So if we look at this first example here, I tell you that these two quadrilaterals are similar, right? So with that said, we have our scale factor is 5 to 6. So we set up our scale factor and we say, okay, 5 to 6 equals. Now I said 5 to 6, assuming that this is the 5 and this is the 6. I probably should have identified that first. So 5 to 6, this is the small to the large equals the small to the large. We got to compare the same, if the order really matters here. So you want to compare, like if we have the small upstairs and we have the large downstairs, then we want to keep those same. So the small is 40 and the large, that same corresponding side is x. Now we'll talk more about corresponding sides in a minute, but I just want you to be familiar with that. Again, we can use cross products to say 5x equals 240. Divide both of those and we end up with x equals 48. X equals 48. Okay, so we can use proportions if we are told that two figures are similar. We can use proportions to solve for that. If we don't know that two figures are similar, we can use proportions to determine if they are similar. And we'll get more into that in the next lesson. So in the meantime, let's try that scale factor, but this time what we're going to do is we're going to find the scale factor. In the previous example, we were given the scale factor. So make sure that you're writing these down in your notebook so that you have these notes to refer back to. So we are told the scale factor find the scale factor for A to B. Again, order is really important here. So we know that A is going to come first and then B. And we're given a couple sides to do that with. So let's say that we do A to B. And again, you can write a ratio as a fraction like I've done here or like this using your semicolon. So A to B means that we're going to have 25 and then the corresponding side would be this one, 30, equals 30 to 36. So there's a couple ways to determine if these are proportionate. So the first thing that we can do is say, okay, well, if we look at 25 over 30, we can divide those both by 5. And if we divide by 5, we end up with, upstairs we get 5, so 5, and then downstairs we get 6. Now let's look at this one. We could say 30, if we divide that guy by 6, we end up with, and then divide the bottom by 6, we end up with 5 over 6. So we were told that these were similar, and now we can confirm it because it's 5 to 6, 5 to 6. So we've got those proportional sides, and we'll talk a little bit more about how to confirm that two triangles are similar, and we'll go into more depth in that in a later lesson. But in the meantime, what we can do with that information is determine our scale factor, and our scale factor is right here. It's just 5 to 6. So for every 5 things that we have here, 5 units that we have here, we have 6 over here. Okay, so let's talk about our next one. We have similarity statements. So similarity statements are vitally important when you're comparing and dealing with similar triangles. So similarity statements, what we have here are, in this example, we have QRS is similar, that's the shortcut for similar, or shorthand for similar, JKL. So these similarity statements are very important because that tells us the order that these things go in. So for example, QR and JK. QR and JK. Those guys are going to be similar. Now I'm using the congruence marks here. I'm not saying that they're congruent, but I'm just using that as similarities to help me make sure that I do this in the right order. So be very clear about that. Then we have RSKL. RSKL. Okay, so what we know now then is so since we know these triangles are similar, there's a couple of things that we have to talk about. When we know that two triangles are similar, their angles are congruent. The corresponding angles are congruent. The sides, however, are proportionate. Proportionate. Did I spell that right? Proportionate? Oh man, you're gonna tell me if I didn't. Woo! Okay. Then these are for similar, I can't spell today. Similar triangles. Okay, there we go. So these are for similar triangles. The angles are gonna be congruent and the sides are gonna be proportionate. So the deal with the angles being congruent is because if every triangle has 180 degrees. So if I have an equilateral triangle that looks like this, I know each side is going to be 60 degrees because there's 3 sides and it's a total of 180. And then if I tell you this is also an equilateral triangle, well, that has 60 degrees in all of those, but they're not the same. You can't say that they are congruent because clearly they are not congruent. So they are similar but not congruent. So our angles are going to be congruent, but the triangles themselves will not be. The sides will be proportionate. Okay, so going back to our similarity statement here, what that means then is we need to be comparing corresponding sides. So if we look at our corresponding sides and angles, so let's deal with our angles first. You see that we have angle Q and angle J. That means angle Q is similar or is congruent to angle J. Then we have R and K. So angle R is congruent to angle K. And we have S and L. So angle S is congruent to angle L. Now, for the corresponding sides, I've done the little hash marks to show that they're congruent, but they're not congruent. I just do that to mark them to make sure, like I said, I want to make that very clear, that they aren't congruent, that they are just similar. But what we can do is write these as proportions. So we have QR here, and that is going to be corresponding to JK here. And then what we'll do is say RS to KL. To KL. And finally, what we have is SQ to LJ. SQ to LJ. Now again, order matters. Notice that I have, for the first triangle, they're all upstairs in the numerator, and then for the second triangle, they're all downstairs in the denominator. Okay, let's use this new information that we have to actually solve it for X. So we're gonna solve an equation here. So let's take this similarity statement. ABC is similar to AGH. So A, B, and C. That means this angle is corresponds with A over here. And then B and G correspond. So B and G correspond. And then C corresponds with H because you can see those guys are there. Okay, so when we go to set up our proportion, it's really important that we look at that similarity statement to make sure we're comparing the correct things. So I see CB here. That comes between our 3 and our 2. And this GH, whoa, helps if I don't move the paper. Our GH comes between the 3 dash and the 2 dash as well. So we have 132 over, and again, that's the 3 dash 2 dash, 3 dash 2 dash, negative 5 plus 7x equals, okay, then we have this guy over here. Again, since I started with the smaller one on the top, I got to keep the smaller one on the top. So 154 over, and this comes between the 1 and 2 dash, and the 1 and 2 dash is 84. Okay, so now we just use our cross products to multiply this. So we say this times this, and remember, if you have addition subtraction in a fraction, protect that bad boy with some parentheses. So 154 times negative 5 plus 7x equals 132 times 84. You do that, you're gonna get 11,088. Okay, so I could distribute that 154 into each of these, but that's gonna give me some huge numbers. Instead, since I'm multiplying it, I'm gonna divide. So there's 2 ways to solve that. I'm gonna take the shortcut because I don't feel like multiplying it out and getting some huge numbers. So now what I have is negative 5 plus 7x equals, and if I take 11,088, divide that by 154, I end up with 72. Okay, now we can solve this equation by adding 5 to both sides. I get 7x equals 77. Divide both sides by 7, and x equals 11. We always go back and we reread our question to make sure that we are answering the correct one. We are. It says solve for x. We solved for x. Kaboom, there we go. We just did that. All right, the next one that we're gonna do is, again, we wanna use those similarity statements here. So this next example, we see TLY. Okay, so that means T, L, and then Y, 1, 2, 3, is similar to CHK. So C, H, and then K. All right, so that'll help us set up our proportions. Now, what we'll do is 25 here is that comes between our 1 and 2 dash, and that comes between our 1 and 2 dash here, so that's gonna be over 10, equals 4x minus 1, and again, that comes between our 2 and 3 dash, and this comes between our 2 and 3 dash, so over x plus 5. Again, protect your addition subtraction in your fractions so you remember to distribute if necessary. I also see that I have a fraction over here, 25 over 10. Make your life easier. Let's reduce that. Both of those can be divided by 5 to give us 5 and 2. All right, now we're ready to use our cross products or cross multiply. So if we take 5 times all that garbage there, we get 5 times all that garbage, x plus 5, equals 2 times 4x minus 1. Okay, now we're ready to distribute. 5x plus 25 equals 8x minus 2. We're going to go ahead and minus 8x from both sides. I always deal with my variables first, just in case my answer is 0. It gets kind of confusing if it is. So we get negative 3x plus 25 equals negative 2. And I moved my x's to my left, even though that gives a negative. You can move it to the right and give you a positive by just out of habit. Okay, so now we're going to minus 25 from both sides. And we get negative 3x equals negative 27. All right, to get that x by itself, we're going to divide both sides by negative 3, and that gives us x equals 9. Okay, so we go back, we read the question. It says find the value of x. We have found the value of x. We have completed the mission for this for this assignment, this question. And that is it for the notes for similar triangles. I look forward to seeing you next time. If you have any questions, let your teacher know. Thanks so much.